4.2 is patterns and linear functions. So you're going to see a lot of like t-charts. You know what a t-chart is? Where you have your x and your y value, and you're seeing how does x relate to y. Okay, so if x is 1, y is 4. If x is 2, what? We did do some with this, yeah. We're going to go further. We're going to do more with it. So first thing that we're going to talk about are dependent variables versus independent variables. What's a variable? It's a letter that's just a placeholder for a number, right? So, dependent versus independent. What is independence? Stands alone. Okay, someone who is independent can stand on their own. Yeah, it's true. Would you say you are independent or dependent on your parents, to your parents?
Independent.
You don't need them.
No.
To put a roof over your head, to feed you, to bring you places. Tax-wise, you are considered a dependent, okay? You depend on your parents for things, right? They take care of you, therefore they get a tax break because they have you. So it's a beautiful thing. So the dependent variable versus the independent variable. The dependent variable changes depending on what the independent variable is. The independent variable is the standalone, I can be whatever I want to be. The dependent depends on what the independent was. So here's how, we'll just write it like this. This one changes in response, that's an S, to another variable.
Is that news?
That one is in. My ends never work on here. I don't know if it's my stylus or the way that I move my hand when I do it. I never write ends well. Okay, so a dependent variable changes in response to another variable. When, in a little bit, we talk about input and output, this is your output. Okay, the dependent variable is your output. Basically, we say it depends, okay? Dependent depends on the other variable, whereas the independent variable doesn't depend on the other variable. Doesn't depend on the other variable. Okay, and that one, the independent, is your input. Okay, so if I have a function, if I have an equation, for example, here's our little example of this, okay? If I have the equation y equals 3x plus 5, y depends on whatever we plug in for x, right? If I plug in 2 for x, it's going to make y 11. But if I plug in 4 for x, it's going to make y 17. So y depends on the x. That means that my dependent variable here is the y. My independent variable is the x. We can pick what to plug in for x, and it will change what we get for y. Okay, dependent versus independent. We're not going to do a whole lot more with that idea, but at times you'll see throughout your algebra career where they're going to say the independent variable or the dependent variable. Just remember the one depends on the other. So y depends on x, because if x changes, then y is going to change as well. Okay? What you're going to be doing with that, and you'll see now how they impact each other in these types of problems, is this. Here's your first example. I want to know the relationship between the number of rectangles and the perimeter. Okay, what is the relationship between the number of rectangles and the perimeter? Okay, so the perimeter of some setup depends on how many rectangles we're putting in the figure. So here's your picture. You have one rectangle where this is 6 and this is 1. We can figure out the perimeter of that rectangle. But what if it were 2 rectangles? And this is 6 and these are both 1. What would that perimeter be? What if we had 3 rectangles? Where this is 6 and these are 1, what would that perimeter be? Or if we had 4 rectangles. These are all 1. This is 6 still. What would that perimeter be? So your problem will look something like this. I'll give you a picture, several pictures in this case, and I want to know what equation could you come up with, what table could you come up with for this, and then could you graph it, okay? We said the input is your x, okay, which is your independent variable. So the one that stands alone, the one that can change on its own is how many rectangles are there. Okay, so that's going to be our x, is going to be our number of rectangles. Actually, let's do it this way. I'm just going to make a T-chart here. So the number of rectangles is my x. Why aren't we erasing? There we go. Okay, x is the number of rectangles. And then my y is my perimeter. So let's just start with, we're going to make a chart for this. In this first picture, right here, how many rectangles do you see? 1, okay? So when there's 1 rectangle, what's my perimeter? Not 6, the whole distance around. It would be 14, right? It's 6 plus 6 plus 1 plus 1. This would be 1, this would be 6. So basically we're saying 6 plus 6, so 12, and 1 plus 1 is 2. So my perimeter is 14. Okay? Move on to 2 rectangles. When there's 2 rectangles there, what's the perimeter? You have 1 and 1 down here. You have 1 and 1 up here. The perimeter is just the distance around. So we just need 6 and 6, so 12, 13, 14, 15, 16. So it's going to be 12 plus, now it's 4, so 16. Okay. What if we have 3 rectangles? What's the perimeter?
18.
This is 6, this is 1, 1, and 1, so 12, 13, 14, 15, 16, 17, 18. So we have the 12 plus the 6 ones is 18. And then for 4 rectangles, it's 12 plus 8. So that would be 20. Okay, so there's your table. When they ask you to make a table, that's what they're asking you for. Figure out the number of the 2 things that they're looking at, okay? We want to try and come up with an equation for how the one relates to the other. So now we're going to call this x and this our y, and we want to say, how does x relate to y? How do I get from x to y? What do I have to do to my x to get my y? Do you see a pattern happening in our work up here? It is adding by 2, but we're not asking how did I get from 1 to 2 and 2 to 3 and 3 to 4. We're asking how did I get from one rectangle having 14 and now 2 rectangles have 16. So it's the relationship between these, not the relationship vertically. I mean, it is adding by 2, and that is one way, technically you could figure it out that way, but I want you to recognize the parts to it. What do you notice in this box? What's always there?
12.
12, right? So no matter what, you are adding 12 to your number, okay? So we know there's a plus 12 involved. Now look at these numbers. So this was 1, now it's 2. This was 2, now it's 4. This was 3, now it's 6. This was 4, now it's 8. What do we do? We multiplied it by 2, right? So we took our x value and we doubled it. So I can say 2 times my x value plus 12 should get me my perimeter, which is my y, okay? So that's one way that you can come up with the equation for that. Look at if there's something that's consistent, then that's going to be plus whatever, okay? And then figure out the relationship between the other part of it. And I'm not telling you this stuff is easy. This stuff can be a challenge. Just know that this is not what we're going to spend the entire chapter on. There's bits and pieces of it here and there, but I want you to get it as best you can, okay? So let's say we're going to graph this then. What variable goes down here? What? The x, which is what? The number of rectangles, okay? So the number of rectangles is here. So what's the y-axis? The perimeter, the other side of it, right? That's our perimeter. Okay? So if I'm going to graph this, you just want to make sure you're consistent. So count by the same thing on the whole axis. So 1, 2, 3, 4. Make sure you space them equally. Okay, and then your perimeter, you can choose what you want to count by. I think it makes a lot of sense to count by 2s because that's what your perimeter is changing by. So you can go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Just make sure that you show that you're counting by 2s. You don't have to write every single number in. If you just show me you're counting by 2s, that's fine. So if we were going to graph this, our first point is one rectangle has a perimeter of 14. So you're going to go 1 on your rectangles on the bottom up to 14. So this was 12, this is 14. So 114 would be that point right there. Your next point was 2, 16. So 16 is this guy. Move over to 2, go up to 16. Okay, next one is 3, 18. So that's here. And then it's 4, 20, which would be there. Do we draw the line in?
No.
Why not? It wouldn't be connected because we're talking perimeter of rectangles. Can you have 2.5 rectangles that you're finding the perimeter of? It's not going to work very well, right? We're talking how many whole rectangles. So this one's just going to be dots drawn in. Okay? Questions on that? Okay. We would say with this that the perimeter here is a function of the number of rectangles. In order for something to be a function, every input, so every x, can only have one y that comes out of it. So when I plug in x to my formula here, I can only get one value for y every time. If I plug in 2, I'm going to get 2 times 2 plus 12 is 16 every time, okay? So if you can plug in a number and always get the same answer for that number that you plugged in, it is a function. Okay, we would call that a function. I'm just going to write that down so you can refer back to it if you need to. A function basically says for every input, which is typically our x, there is exactly one output. Oops. Which is our y. Okay? So when we talk about a linear function, what do you hear in the word linear? A linear function. Brought me a sweatshirt. I want that sweatshirt. I really do. I like those a lot. Okay, anyway, a linear function means it's a line, okay? You're making a straight line if it's linear, right? You see the word line in there? Now, for a linear function, it just can't be a vertical line. So, we'll say the graph is a non-vertical. So it can't be a straight line up. It can't be vertical. Non-vertical line or part of a line. Okay? That is a linear function. Okay, here's what we're going to do. I'm going to give you one more problem, like that last problem where you had to come up with the chart, you have to come up with the equation, you have to come up with all of that. I think I'm going to pick a different one, though, than the one I was going to do. Hold on. Let's do this. Okay, so for this one, and you're going to have to bear with me on the drawings because the drawings are not going to be awesome, but that's okay. If we have one hexagon where all the edges are 1 versus if we have 2 hexagons and you don't necessarily need to draw these pictures all out if you don't want. If you want it to refer back to, then go ahead and draw it. But versus if we have 3 hexagons. Looks like a little fence. Okay, and all your edges are 1. I'll give you a second to draw that if you're drawing. Okay, so this one's just like the last one. It's rectangles and perimeter. Now this one is hexagons and perimeter. Okay, so for our T-chart, we have the number of hexagons and the perimeter of them. Okay, so for our T-chart here, we had 1 hexagon, 2 hexagons, 3 hexagons. Okay, we're trying to figure out what is the relationship between our hexagons and our perimeter here. Okay. All right. Now let's think about this. In the last one, those vertical sides stayed the same always, right? We always added what in that last problem? The 6 and the 6, right? Which always added up to 12. So now look at your pictures here. The thing that is always staying the same, staying consistent, you could kind of think of it as that same setup. These two ends are always staying the same. They're the same here, they're the same here, they're the same here. Okay? What's changing is how many times we do our up and down. What are you guys doing right now? Huh? I have no idea what you're talking about. I love the like guilt. Like I start asking a question and you both are like, huh? I don't know. What? I don't know. I don't know what you're talking about. Oh yeah. Oh yeah. Okay. Anyway, what's the perimeter of the first hexagon?
6.
It's 6, right? If you go all the way around, you have your 2 on the side, and then it's 1, 2, 3, 4. So we have our 2 on the side, plus the 4 that are doing our up and down. So our perimeter there is 6. Okay? What's the perimeter of the next one? 1, 2, 3, 4, 5, 6, 7, 8, plus the 2 that we had there. Right, that is what you meant. So the 2 on the side plus the 8 on top and bottom would give you 10. Okay, now look at that third one. You still have your 2 on the side, but now you're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 2 plus 12 would give you 14. Okay. Our process is to figure out how did we get there. So our 2 on the sides always stayed the same, right? This 2, this 2, this 2. So we were always adding 2 to the process. Now you ask yourself, how does this number become that number? How does this number become that number? How does this number become that number? You were multiplying by 4 each time. So you're taking the number of hexagons, we're taking the x, and we're multiplying it by 4. So that's 4 times x being added to the 2 that stayed consistent on the ends the whole way through. Okay, your 2 ends always stayed as 2 units. Okay, so we would say our equation then, our perimeter, is y, and that should equal 4 times the number of hexagons plus 2. So if I had 10 hexagons, you should be able to find the perimeter really fast right now. What would 10 hexagons have a perimeter of? 42, right? You would plug 10 in, and you would get 42 out, right? 4 times 10 plus 2. Okay? So there's your chart, there's your equation, and then your last thing would just be to graph it. I just threw a random number. I said, what if you had 10 hexagons? What if you had 20 hexagons? If you had 20 hexagons, you'd plug 20 in here. 20 times 4 is 80, plus 2 would be 82. So if you had 20 hexagons, your perimeter would be 82. Right? So I just said, what if? Like, here's a number. I didn't get it from doing anything here. Okay? Okay, so if we graph this, where is our, well, what's going to be on our x-axis? What's our label there?
The number of hexagons.
Mm-hmm. So your x is your number of hexagons. What's your y? That's your perimeter. Okay? So then when you label this is hugely important, you guys. You have to space them evenly on each axis. So on the x-axis, I only have to go up to 3. So 1, 2, 3 is all we need. On the y-axis, I have as low as 6 and as high as 14. So I would probably, again, just count by 2s like we did the last time. So 2, 4, 6, 8, 10, 12, 14 gets us high enough, starting at 2 here. So at 1, we went 1, 6, so 2, 4, 6 would be here. 2, 10 would be about there, and then 3, 14 would be about there. Okay? Is that a linear equation? a linear equation, a linear function. It makes a straight line, right? If I were to draw a line in, it would be a straight line, so that is a linear function. If it makes a straight line, we say it's linear. Yeah. Okay? Just disappeared.